Let's come now to the different product classes we have for NFC. An NFC device, as it is used in the smartphone, has to support all operating modes: reader-writer, card emulation, and peer-to-peer mode, as it has to change its functionality depending on the application it's being used for. This is shown in the middle of the slide. But if you have a look at the different end equipments, not each NFC product in each end equipment has to support all operating modes. For example, a door lock system does not have to emulate a card transponder, and for an NFC transponder in a poster, you do not need a device which supports the reader-writer mode. Therefore, we have more dedicated devices depending on the application requirements. On the left side, you see the NFC reader-writer and static tag, similar to what we have in a traditional RFID system. In the middle, as said, we have the NFC device, which supports all operating modes, and on the right side, we have two new classes of product, a dynamic tag and a smart tag. So what is a dynamic tag? A dynamic tag is a transponder device which has, in addition to the NFC wireless interface, a wired interface to connect it to a microcontroller or a host system so that the microcontroller can dynamically shift the data content into the memory of the transponder as it's required in the pairing application, especially for Wi-Fi, or if a transponder should be used as a service interface. The smart tag devices are a new class of intelligent transponders where the NFC communication possibility is combined with the possibility to connect sensors and the functionality of a microcontroller, all combined into one device. Let's have a look now at what products TI is offering in the different product categories. As NFC reader-writer, we have our TRF7970A product family, which includes several members supporting multi-protocol or specific standards. For the static tags, we have the Tagged HFI product family consisting of devices that are compliant with ISO 15693 and ISO 18000-3 Mode 1. In NFC, this is recognized as NFC Tag Type 5 technology. The products are available as die delivered as a wafer with different memory sizes, coin transponders, and inlays in several different form factors. As NFC devices, we have the TRF7970A, which is also pin-for-pin compatible to the TRF796X reader-writer devices, so that an expansion of the functionality from reader-writer to complete NFC functionality and is easy and only requires a firmware upgrade of the microcontroller. As dynamic tag, we have the RF430CL330H, and as smart tag, we have the recently introduced RF430FRL15XH, the industry's first fully programmable system-on-chip sensor transponder family. TI offers a complete portfolio of reader-writer devices to support the application requirements with optimized solutions. We have a very differentiated transponder portfolio ranging from simple static tags to dynamic transponders all the way up to highly integrated, fully programmable sensor transponders with the best-in-class RF performance. Supported by a strong firmware and software stack offering a broad integrated development environment and TI reference designs and application support, we enable fast and easy development of highly differentiated system solutions. Let's have a deeper look into the products, starting with the TRF7970A. The TRF7970A is an NFC device which supports near-field communication standards NFC IP1 and NFC IP2, also known as ISO 18092 and ISO 21481, which defines the selection of any of the possible communication modes, peer-to-peer, card emulation, reader-writer. It also supports ISO 14443 Type A and Type B, FELICA, and the ISO 15693 protocols. Has integrated encode, decode, and data framing capability for data rates up to 848 kilobits per second, a wide supply range from 2.7 to 5.5 volts, large FIFO buffer for RF communication, relevant NFC software stack libraries, and an innovative RF field detector allow for easy development efforts and robust, cost-effective designs. Finally, 8 selectable power modes and ultra-low power operation enables the longest battery life in the industry. The devices also offer unparalleled flexibility via the various direct communication modes on the device to allow implementation of custom protocols as well as other 13.56 MHz standards. The receiver system enables AM and PM demodulation using a dual input architecture to maximize communication robustness. The device has also a very low power RF field detector with programmable wake-up levels to detect if an RF field is present and another NFC device wants to communicate with it. Coming now to the NFCLink firmware and software library that TI is offering to support the development of our customers. NFCLink is an industry-proven modular firmware and software solution from hardware level up to operating system API to support TI's family of TRF7970A transceiver devices. With NFCLink, TI provides embedded standalone firmware and an NCI standard-based interface to Android, Linux, and Windows 7 and 8 operating systems, which simplifies and streamlines the development of all NFC operation modes across TI's entire embedded processing portfolio of MSP430 microcontrollers, ARM-based MCUs, and processors. From highly energy-efficient systems to high-performance devices, NFCLink provides the developer, integrator, a complete and proven high-quality NFC firmware and software bundle to use with TI's broad portfolio of embedded processing products to accelerate customers' time to market by minimizing the in-depth protocol and device knowledge required for NFC applications. Now let's have a look into the dynamic tag, the RF430CL330H. The Texas Instruments Dynamic NFC Transponder, RF430CL330H, is an NFC tag type 4B device which combines a wireless NFC interface and a wired SPI or I2C interface to connect the device to a host. The integrated SPI or I2C serial communication interface allows reading and writing of NDEF messages into the integrated SRAM, and the NDEF message can be accessed wirelessly via the integrated ISO 14443B compliant RF interface, supporting up to 848 kilobits per second. This allows NFC connection handover for an alternative carrier like Bluetooth, Bluetooth Low Energy, RF4CE, and Wi-Fi as easy, intuitive pairing process or authentication process with only a tap. No keys or parameters have to be typed in, simply touch the two devices together. The RF430CL330H can also be used as a general NFC interface or service interface to enable different end equipments to communicate with the fast-growing infrastructure of NFC-enabled smartphones, tablets, and notebooks. It also has the capability for a wake-up based on the presence of an RF field. On the lower right side is the development board shown. The green board with the RF430CL330H device on it and the antenna around the PCB can be connected to microcontroller boards with the EM headers populated in the picture. We also have a booster pack available which can be used with the Launchpad ecosystem of microcontroller development boards. To prove and ensure the interoperability with the NFC-enabled smartphones and compliance to the NFC specifications, We have gone with the RF430CL330H through an NFC compliance test with an external test house. In this slide, you see the test result summary that we have passed all tests without deviation from the technical specifications. So the RF430CL330H is the first fully tested and compliant NFC interface device. Now let's have a look into the RF430FRL15XH, our new sensor transponder family. It is a highly integrated system on chip which combines a programmable MSP430 microcontroller core with the ISO 15693 NFC wireless interface, a 14-bit Sigma Delta analog to digital converter for connection of analog sensors, and an SPI or I2C interface for connection of digital sensors or connection to a host system. It has an embedded application code in ROM which manages the RF communication and sensor readings and provides the ultimate configuration possibilities for the device. Developers can configure sampling rates, measurement thresholds and alarms, and much more. The available universal FRAM memory allows data storage of the sensor measurement data as well as the extension and adjustment of the integrated application code according to the application requirements. The device can be used for batteryless operation completely powered out of the RF field, harvesting the energy from the communicating reader device, or if the device is used for a data logging application, it can be used with a single cell 1.5 volt battery. Intelligent power management, including an RF controlled battery switch, ensures long battery life even if the finished product will be placed for months onto a shelf with an installed battery.